It's another year. Summer is here, and I have bought a new air conditioner, a new used air conditioner, lightly used, for my car with remote control. Whirlpool. The model number I think is ACQ 068MPO. If I'm wrong with that, you'll see an annotation in the video right now. So it's 6,000 BTUs, 10.7 EER in the trunk, and I might use this to help fill in the hole gaps, but they seem a little bit small. I might use towels instead. This is clearly a Redneck operation with my 2,000 watt continuous inverter in my Trip Light 1200 LC or something, or 1800 LC. It basically boosts up the voltage. Yeah. The inverter is sometimes a little bit buggy. You turn that on first, and then you give it a load a few seconds later. There we are. It's boosting the voltage right now. Power. There we are. And my trunk, I'll open the trunk. Exhaust fan. This isn't fully done yet. This clearly isn't working, but there are gaps here. I might try to mount the fan above the trunk or something else, but this is just first draft for the year. ATX power supply, or rather AT power supply, mechanical switch, air conditioner, and I still haven't, let me shut this off. The next thing I'm going to have to do is take out the overheat protection and the overcurrent protection on the compressor. And that's on the top of the compressor. Take off the shell of the chassis here and take off the top of the compressor and bypass that protection, because right now the compressor isn't turning on because it thinks it's hot. It's not that hot, but that's the first step, because this is clearly not easy on the unit, and it will try to protect itself and shut itself off on a hot day and not cool me off. So next I'll show you my attempt at doing that. I've just done it with my Gold Star air conditioner from last year, and we'll see how we do it with this Whirlpool. I have the top cover off now. The screws are right there. And that's the compressor. This is the nut. Taken off with this thingy. That's what I call this tool, a thingy. Pliers? Yeah, that's it. And there's the protection device right there. I do believe well, yeah, because obviously this side doesn't go in the compressor. It's just a doodad. This side goes into the compressor. So power goes in through the yellow, I would imagine. Then it would go out to the black to this module here. So we have to disconnect this black, put this yellow right there to bypass this. Back at you in a minute. Well, a little trouble. I got this off, right? And this normally goes to where the yellow was plugged in, which is this terminal right here, but you see it has a post with the normal connector welded to it or whatever. So this coming from the AC source or from the circuit board, from the capacitor inside, will not fit over this. And so I think all I have to do, if I can get this to focus, is to take out this plastic casing, because it's preventing it from plugging in. Otherwise it should work. So I'll see if I can get that to work. I almost have it taken off. I've been using wire cutters, and I'm able to put it on that terminal now. Where is it? Right there, with the post. So next scene, I'll have this plugged in and I will test it out, see if the compressor turns on immediately or not. Okay, let's see if it works. 64 degrees. Sweet. I'm smelling fumes. Can't wait until I get an electric car. Maybe in 20 years or so. There it is. I wonder if this, this device also has the 3-minute timer, you know, when you shut off the compressor, like turn off the unit and then press the power button again, and the compressor won't kick on again for 3 minutes to protect itself from pressure. I wonder if this was doing that protection, or if it was some circuitry in there. Hopefully it was this. So I've cut out over current, which is over load protection, over temperature protection, and the timer. We'll see. I'm going to test that right now. Shut it off. Now turn it back on. Aw, 3-minute timer still going, no compressor. How do I get past the timer? I can either hardwire the compressor to the cord, the capacitor to the cord. I want the capacitor in line with the compressor, so I have a good buffer there. But I wonder if I unplug the unit, you know, unplug, then I wait like 20 seconds. I wonder if the memory will, in the logic chip, will reset. About 10 more seconds, then I'll turn on the power again. 14 volts. Okay, back on. Hey, hey. Okay. My next step will be filling in the holes, you know, between the trunk and the back seat, and also duct work to go from here to my body, because I'm not going to attempt to cool the whole cabin, you know, the whole cabin. I'm not going to attempt to do that because it's just too big of a space, and there's too much, you know, greenhouse, too much sunlight. So I'm going to have duct work going from the output to the front seat, or to the center column, and going from there. So we'll see how that works out. Day 2 of my air conditioning project for 2011. So this is a 1999 Honda Civic, air conditioner's not in it right now. Will be later today probably. This is by no means a perfect air conditioning system. You know, it's hit and miss. When I'm in rush hour traffic idling, it will, you know, the alternator can't keep up with the low engine RPM, so the voltage lowers to my inverter, and then the inverter complains and eventually shuts off. So this is by no means a perfect solution, so don't count on it if you try to do this with your vehicle. Not unless you strap a Honda generator to your roof or something. Anyway, this is an electronic load detector, ELD, and this is a fuel-saving device. It is used to help the alternator run cooler and use less energy, mechanical energy from the engine when the load on the electrical system is low, as in your stereo's off, your fan is off. It will throttle back the alternator, so the output of the alternator is around 12.1 to 12.3 volts going to the battery terminals, instead of the full voltage of 14.14 or so when the alternator is running full field. I think that's the right terminology. So anyway, this is annoying because sometimes it does not detect the load of my inverter, which is connected, you know, these big huge wires here. It does not see this load. The ELD does not, so it throttles back the alternator when I absolutely do not want it to. So I'm trying to remove this device right now. Canadian Honda Civics, I've heard, do not have this. Some other countries do not have this, so this is optional. It might save a little bit of fuel, but I do not want it for the summer. So the first step is removing the 80 amp fuse here and the 40 amp fuse from here. See these guys? 80 amp, 40 amp, black and green. And I'm having a little trouble removing this. It doesn't want to just pop out. Put this guy here, like that. This guy here, like that. And then take pliers. If I can do it, I'll switch hands. But there's resistance, and I don't know what it is, but I'm going to be careful. I don't want to break it. Keep you guys informed. I finally managed to pull it out. This is the orientation, okay? Goes in like this. This is the other side of it. This bottom part is where the plug plugs in. It is a 3-pin plug, as you can see. It was really hard to get out, and I was thinking, oh my, I might rip out the plug or something because it wasn't coming up. I had to really pull hard. The reason was a little bit of the white plastic of the plug apparently is melted in here, so it got hot at some point. Maybe last summer, who knows. But this device is out, so I kind of put this away, I suppose. And then I put my plate back in. What's the orientation? Like this. Bada bing, bada boom. Put my 2 fuses back and hope I don't fry my computer when I turn on my car. Let's see. Okay, the device is out. The fuses are back in. Let's see what happens. My trusty cigarette lighter voltmeter. .446. Okay, we're not frying anything less. Let's rise up the RPMs. a change. Alright. So, it looks like you can remove the ELD on your Civic without frying your computer. It's just from another YouTube video I've seen, and from a little bit more research that I've done on the internet, on civicforums.com and on Google, from Google. It just acts like an ammeter, that's it. It's just an ammeter, so in other words, this won't tell it the output of the alternator voltage or anything, so yeah, so that's solved, and I'll report back in an annotation in the video right now how this helped me with the air conditioning project. Paper towels for insulation. Helps to wedge the unit in so it won't jostle around and go back into the trunk or something while I'm driving. The unit should stay pretty stable with the paper towels wedged in between it and the car. It's in fan only mode, but it's at full speed, so this is pretty much what I will hear while I'm driving. Pretty quiet. Pop the trunk. Filling in the air gaps. Lots of airflow with the Delta fan. AFB1212GHE, 12 volts, 3.24 amps. So the project is pretty much all done, except for the ductwork. I don't think that will be a success. I bought some semi-rigid ductwork at Home Depot, an 8-inch diameter, 7-inch diameter, 8 foot long, and I can't really get it to shape inside of that hole there. It just kind of, gets smashed up, and no air flows out the end of it. So I don't think I'm going to be able to channel air to the front seat. It'll just have to cool the whole cabin. Alright, see you guys later. See, it didn't work too well. Output from the air conditioner. Could have done a little bit better there. To the front seat. Not much airflow. Oh well.